am a clinical scientist based at the All Wales Medical Genomics Service. So I work in the reproductive and neonatal health service. So we primarily take care of women in the prenatal period and shortly after babies are born. And the project that I'm going to talk about today is a pilot study looking to create a genetic test for women in suspected miscarriage cases. Has that changed, hopefully? So approximately 20% of clinically recognised pregnancies end in a miscarriage. Of those occurring in the first trimester, around 50% are due to chromosomal abnormalities in the fetus. In the majority of cases, these chromosomal abnormalities have arisen sporadically, and the chances of it happening again are low. However, for about 1% of couples, recurrent miscarriages occur, so they have at least two. For a subset of these couples, they may actually be carrying a balanced chromosomal rearrangement, which can result in the chromosomal abnormalities in the fetus. Therefore, current guidelines from the Royal College of Obstetricians and Gynecologists recommend that for a couple experiencing their third miscarriage, the fetus should be tested for chromosomal abnormalities. As well as providing answers for these couples, this genetic result may inform the management of future pregnancies. So the test we currently offer in Wales is called Array-CGH, which tests the whole genome for chromosomal imbalances that may have resulted in the pregnancy loss. This test is performed on fetal tissue, which is obtained from the products of conception, which is the material that the woman passes as she miscarries. This testing strategy can be very difficult for the patients, as it can often happen when the patient is at home when the sample needs to be collected. The tissues can be very difficult to distinguish, and this can result in valuable fetal tissue being lost. In addition, the collection process can be quite distressing for patients. This testing strategy also has a number of limitations from a laboratory perspective. The samples we receive can often contain a combination of maternal and fetal tissue. It can be very difficult to isolate the fetal tissue for testing, meaning that the test can often fail due to maternal contamination. A recent audit showed that 81% of the products of conception we received in the lab had some level of maternal contamination. 34% were actually entirely maternal in origin. The test that we perform, the Array-CGH, can only tolerate maternal contamination of up to 10%. Therefore, we estimate that approximately 60% of the samples we receive are unsuitable for testing. This means that these patients not only have had to undergo a distressing process, but they're not going to receive the important results they need. Therefore, we believe an alternative approach is needed. We are hoping to implement a new testing strategy which will replace this current test using the products of conception. During a pregnancy, the placenta sheds cells. These cells can degrade and release cell-free fetal DNA into the mother's blood. This means that the mother's blood contains both maternal and fetal DNA samples. We're hoping we can develop a test that can use a blood sample from the mother that can look for chromosomal imbalances in the fetal DNA present in the blood. This approach would have numerous benefits. This wouldn't require a fetal tissue sample and only require a maternal blood sample. So this would be a much easier process for our patients to go through. Furthermore, this new approach would take into account the fact that maternal DNA is present. Therefore, the maternal contamination would no longer be an issue. This would be a much more streamlined process for the lab, resulting in fewer failures and more patients receiving important results. So this project aimed to investigate the potential of this new alternative testing approach using maternal blood samples. The initial aim of the project was to obtain technology capable of performing this analysis in the laboratory. Next, we want to perform a proof of principle, which will determine whether this new approach is capable of detecting the fetal chromosomal abnormalities following a miscarriage. And finally, we would want to compare this new approach to the current testing strategy and determine whether this will offer an equivalent or improved service to what we currently offer. So the first aim was to obtain new technology capable of performing this analysis. In 2020, the laboratory installed the Illumina VeriSeq solution. This technology is an automated approach capable of taking a blood sample, using the blood plasma, isolating the cell-free fetal DNA, and running an analytical pipeline that can detect chromosomal imbalances. We are currently using this instrument for other clinical tests and is ready to run on blood samples from following a miscarriage once we've collected the project samples. The second aim of this project is to perform the proof of principle. So can this instrument detect the fetal chromosomal abnormalities in the maternal blood sample following a miscarriage? In order to do this, we need to collect blood samples from women undergoing miscarriages. Patient recruitment and sample collection has been an ongoing collaboration with the Obstetrics and Gynecology Department, based at UHW in Cardiff. Together, we have developed a sample collection protocol with input from a patient advocate from the Stillbirth and Neonatal Death Society. We received ethical approval for this project in 2019, and sample collection began at the end of that year. However, once COVID took hold in March 2020, all project recruitment in Cardiff and Vale has been halted. Once the first wave subsided, projects were able to resume recruitment in September. However, we found it a struggle to regain the momentum of the project. Our collaborators in OBS and Gynae have been significantly disrupted during the pandemic, with the ward being relocated to accommodate for the care of COVID patients. They were also impacted by numerous staff absences, and as with all of us, their patients remained their first priority. This resulted in a reduction of patient sample collections. Although this part of the project has been stagnated, both departments are keen to continue the project once it becomes more feasible. And now the technology is ready in the lab, we are ready to proceed once the samples have been collected. Our final aim for this project will be to compare the performance of the new test with our current test. The data we receive in the stage 2, once we've collected our patient samples, will provide us with evidence as to whether this approach will work. The data will be used to apply for further ethical approval in the future to directly compare the results from a maternal blood sample with the results we obtain from a products of conception sample. Data from other labs is indicating that in 59% of cases, the same result is achieved from both a maternal blood sample and a products of conception sample. Although few studies have been carried out so far, this is promising evidence that this alternative approach may be successful in the future. As I've hinted upon, there's been a number of challenges during this project. It hasn't been easy managing the collaborations between different departments, and both genetics and obs and gynae are very busy and can often have multiple competing priorities. Especially during the pandemic, efforts were focused on maintaining routine services to meet patient demands. This has resulted in project work falling down the priority list. In addition, multiple people involved in the project, myself included, have had to change in job role. Maintaining the project momentum whilst handling numerous changes of circumstance has been difficult. However, I've really enjoyed my experience of being a Bevan Exemplar. The networking and workshops that were held both in person and online delivered good tools to use to get people excited about innovation and gave me the confidence to engage and pursue new developments. This project has taught me that despite the best of intentions, things do not always go to plan, but it is important to remain motivated and enthusiastic about an innovation you believe in. So I'd like to thank the patients who have donated their samples to this project, my collaborators in OBS and Gynae, and my other project leads, Sian, Sarah, and Monique, and the staff who were vital involved in the installation of the VeriSeq solution at the lab. Thank you for listening.